short online tutorial on the topics electrolysis. And when we talk about electrolysis basically refers as the chemical decomposition of a compound or a molten solution which allow the flow of electric current through them. Or we can also define as the composition of a component in a liquid form which allow the passage of electric current through them. Or we say is defined as a dissociation of a solution that specifically allow the flow of electric current due to the presence of ions or due to the dissociation of ions in them. So in a nutshell, we have what we call electrolysis, which is the chemical decomposition of a compound in a molten solution or in a liquid solution which allows the passage of electric flow of electric current through them. For instance, we have our copper 2 sulfide. The copper 2 sulfide can allow the passage of electron. It says that the copper will become plus and the OH minus. Can you see this? Because of positive and negatives, it allows the passage of electric current through them. That's what we refer as chemical electrolysis. And based on this electrolysis is being postulated by a scientist which is called Michael Faraday. And the Michael Faraday specifically postulated two laws. We have what you call the first law of Faraday's, and we have what you call second law of Michael Faraday's. So let's see the first law. What does the first law say? The first law of Faraday's. The first law of Faraday says that the mass of substances deposited or calibrated during the electrolysis is directly proportional to the total quantity of electric current that passes through the given circuit, respectively. I will repeat. The Faraday's first law says that the mass or the fixed mass or the mass of a substances being deposited or calibrated during the electrolysis is directly proportional to the total quantity of electric current that passes through the given circuit or the cells, as the case may be. And the Faraday's first law says that the mass is directly proportional to the current that flows through the given circuit. We call it equation 1. If you now go back to the electrolysis, what is electricity? Electricity, which is the current I. And the current are able to know that the current is equals to charge divided by what? Time is what we refer as electric current, meaning I is equals to Q over what? T. We call this one equation what? Equation 2. Hereby, we have what? I is equals to what? Q over what? T. Therefore, here in nutshell, you cross multiply. When you cross multiply, what do you have? You have Q. We have what? Q is equals to IT. We call this one equation what? Equation 2. In a nutshell, we can also say that the mass is directly proportional to the charges. Again, I beg your pardon. Mass is directly proportional to the total quantity of the charges that pass through this given circuit. And therefore, in equation 3, we have Q is equal to what? IT. You can substitute the Q equation 3 in where? Equation 1. We have what? Mass is directly proportional to what? IT. We call this one equation what? Equation 4. Thereby remove the proportionality and you put Z. We call it equation what? Equation 5. Where we have mass is equals to ZIT. We call this one equation what? Equation 6. So which means the mass of the given substances is equals to IZT. What is mass? The mass is defined as the amount of substances being deposited or calibrated, and its SI unit is either kilogram or gram, as the case may be. What is I? I is the what? The current that passes through the given circuit, and it's always in what? Ampere. Then we have the time. The time is time taken for the current to flow within the given circuit, and it's usually in what? In seconds, as the case may be. What is Z? Z is a chemical equivalent. What did I say? Is the what? Chemical equivalent. Chemical equivalent, as the case may be. This is all about the first law. Let's talk about second law. The second law says that the second law of electrolysis, it states that the different masses of element or the different masses of substances being deposited or calibrated during the electrolysis is directly proportional to the chemical equivalent. I will repeat. The second law says that the different masses of elements being deposited or calibrated during the course of electrolysis is directly proportional to the chemical equivalent, meaning the mass is directly proportional to the chemical equivalent. That is what the second law of electrolysis says, and there is also various calculations that can be done on this. I beg your pardon. With this, I will stop here. I remain my humble self, Muhammad Nasser.